Yeah, welcome. So, in today's class, we are going to be stepping into the second aspect of control flow, and it is going to be for loops. We are going to be looking at for loops today. I might as well just remove conditionals from this place. For loops. So, here we are going to be covering for loops. So, now, what are loops generally? In Python, loops are actually part of control flow in Python, and it is our way. In our class on conditionals, we mentioned that conditionals help us to actually you know explain to the system how we want things to be executed. So we don't want every single line to execute. We just want some specific lines that meet a particular threshold. If they fulfill a criteria, execute them. If they don't execute that block. So that's what happens in inside conditional. But in for loop, what we do is we want to iterate, we want to do things over and over and over again for a specified amount of time. So we want to do something thrice, we want to do something four times, we want to do something 1,000 times. So for loop is the way for us to do that thing repeatedly. For example, let's say we want to write a program that says hello 5 times. So we want to say hello 5 times. One thing that you could do is you could do print hello, print hello, print hello, print hello, which doesn't make sense. So instead of doing print hello like this, hello world, then copying this and going one, two, three, four. I don't know. He's five already, so we can run this. And it says hello world, hello world, hello world. Imagine you want to do 1,000. This is a terrible idea. Even if you are not doing it 1,000, there is this rule in Python that you should really not. It is not like it's an unwritten rule in programming generally that is do not repeat yourself. So how do we fix something like this? The way to do that is going to be to say for, and whenever we want to start a for loop, we use the keyword for, right? So we can go for greeting, or let's just say I. Let's start like that. Something very simple. For I in range 5, print hello world. What are we trying to say? What we are trying to say is if, okay, let's first look at the anatomy of a for loop, like the structure of it. So the first thing is you have the for keyword, you have this thing called the iterator, which is like a placeholder value that we use to represent each one instance of the iterable. So these are iterable. This is the range that we are iterating over. So we are saying one, two, three. Don't forget Python starts counting from zero. So 0, 1, 2, 3, 4. Now, in this particular situation here, for zero, I is going to firstly temporarily take a value zero. Then after that round is completed, it takes value one, value two, value three, value four, till the last one and it stops. So if I should come here and print this, you can see that we have hello world and hello world, hello world, hello world, like that. So that is basically how this works. So we are saying for the structure is for something in range this, print this. Now this is just us creating our range at the runtime. So sometimes you have an existing list, you know, sets, tuples, anything, and you want to loop over it. So for example, you have a list of names and you want to greet those people. So you say names equals So write a program that goes over a list of names and greets those people. So I'm going to say for, no, let's firstly define our names. So we said names equals, and we can go Steph, Seth, James, Paul, and Chris. Then we can come here and say for name in names. So basically, another like row, unwritten rule is instead of saying for I, for J, for K, for all of that, it's better to actually use descriptive things as the iterator. You could use anything here, anything. Well, it makes for good readability if you put something that is descriptive and people just know what you're trying to do. You say for each name, like for name in names, what do we want to do? We want to print f string I name. How are you? Then don't forget to say for name, this is a temporary variable. We didn't create it anywhere. It is actually at this runtime that we are doing that. So if we run this, we're going to say I Steph, how are you? Which is the first person. We're going to have I Seth, how are you? We're going to have I James, how are you? And it does not really have to be a list, even if it is a tuple, it is still going to work. And a sorry, it is still going to work. But it is not going to work in the case of a dictionary, at least not directly. So if we change this to a dictionary, just to show you, or let me just copy all of this and paste it here. And I'm going to say, write a program that iterates over a dictionary. So we can go Steph, and let's start with surname, which is Corey. We can go here also, Seth, and that is also Corey. James here is going to be Arden, and Paul there is going to be George. George. And Chris here is going to be Paul. And let's just like make this cleaner a little bit. Take this in next time. Perfect. So if we run this, it is not going to work. It's going to try an error. If we run that, oh, excuse me, it is not going to try an error. It is only going to return the keys. It is only going to like return the keys. So what you want to do, this is like the equivalent of saying for name in names dot keys, and we run this, it's going to be the same output. But what we actually want to see is we want to see um both names, Steph and Corey, James and all of that. So what we can do is, and this is what happens whenever you want to loop over a dictionary. First thing is you call dot items, and you go for name, comma, surname in names of items. Then we can say I name surname. How are you? So we can run this and it says I Steph Curry, how are you? I Seth Curry, how are you? I James Harden, how are you? I Paul George, how are you? I Chris Paul, how are you? So I hope that makes sense. So whenever you want to loop over a dictionary, it has two elements. So you firstly do dot items, and I showed the what these dot items, what it does in the last session on basic data structure. And what it does is it actually return the key value pairs packed together as a tuple. So it returns them as a tuple. That's what happens. Now, so we already see how to loop over a range, how to loop over an iterable that is either a list, set, dictionary, tuple, or whatever. And we've seen how to also loop over a dictionary. So the next that we're going to look at is, and you can have nested for loops, which, isn't also a good idea when it gets really large. So, for example, let's say nested for loops. So let's say we want to do, we have two lists. I cannot come up with a question in my head, but let's say we have two lists, and list A is list of numbers, and one, two, three, four, and we have list of letters of vowels because one A B C A E I O U A E I O U. So if we want to loop over these two things together, we can say for number in numbers, then go inside it and say for letter in vowels. Then we can print f string. Then we can go number, then vowel. So now what we are trying to do is we are trying to mark letter, number, letter. Right? So what we are trying to do is we are trying to merge. We are using two for loops, and we are trying to merge each of these number with a vowel. So it's going to go one A, one E, one I, one O, one U, two A, two E, two I, like that. So if I should run this, we get this long thing. Like I said, it goes one A, one E, one I, one O, one U, two A, two E, two I, like that. So that is, a case of nested for loops. So you can have two for loops inside each other. You can have three for loops, but you really shouldn't go. Like I say, you should not. If you have to nest things a lot, it is going to, like, one, not make for a very readable code. Two, it is going to bring complexity in terms of the time it takes for execution. Right. So that is the case of nested for loops. So let's look at situations where we would want to incorporate for loops with conditionals. Conditionals. So a simple example is going to be to write a program that returns all the even multiple of 3 between um, 1 and 50. So what we want to do is we want to return a program that returns all the numbers that are even numbers, and also 3 can go in them. Basically, 2 can go in it, 3 also can go in it. So what we want to do is we want to create an empty list for us. So say even bucket, let's call it bucket. Let's just call this bucket. So it is inside this bucket that we're going to be dropping all of our checks, right? So this is an empty list. Now what we want to now do is if you want, you can create a range to start with, or you can do it in the for loop. So you can say for number in range 1 comma 51, right? So we are saying for number in range 1 to 51, that is give me the range of numbers between 1, stop at 50. So what we want to do is we want to make a check. We want to say if number modulus 2, modulus 2 equals 0, and number modulus 3 equals 0 also. That is, 2 can go in it, which makes it an even number, and 3 can also go in it, which makes it a multiple of 3. Then put that number in the bucket. And how do we add new things to a list? Is dot append. We say bucket dot append. And what are we appending? We are appending that number. So after all of the execution, and we can always come here and say else, what should happen? If not, you can say pass. Or basically, you might not just like put anything here and it's still going to execute. So if you print out bucket now, after execution, we run this, we see that it returns all the numbers that are both even and multiples of 3. 6, 2 and 6, 2 and 3 can go in 6, 2 and 3 can go in 12, 18, 14, 30, 36, 42, and 48. So that is basically one implementation of combining um, conditionals with for loop. Let's take one more, and the other one that we're going to take is we're going to say write a program that returns all the prime numbers between 1 and between 1 and hmm, between 1 and what? Between 1 and 50 also. We want to return all the prime numbers between 1 and 50. So what are we going to do? We can firstly get our bucket out again, and it's also going to be an empty bucket. So we can say for number in range. Now, what are prime numbers? Prime numbers are numbers that only one and then self can go. Nothing else can divide that number apart from one and that particular number. So that means we don't check 1, we check 2. We start from 2. Let's say for number in range 2 to 51 to 50, because also that number, we don't want to capture that number. So this range is our way of excluding 1 and excluding 51. So we're saying 2 to 49. So what we want to do is we want to say if the number that we are checking, if anything, and this is where I want us to think about it. Firstly, we take uh let's say we take 2, right? And let's make this really simple. Let's say we start with a number, and the number that I want to check, the number, so we are going to call this num. Oh, no, let's call this number. So let's call this one number underscore to check. This number that we are checking, and the user is going to have to supply that number, right? So we are going to do int input, enter the number. I'm trying to make this uh very, very simple for now. I don't want to write multiple loops. So we are going to adjust this. So we're going to write a program that returns, that checks. First, let's write a program that checks. That's an easier one. Checks if a number is prime. So once we understand how to check if a number is prime, then we can now do the other. So write the program that checks if a number is prime. or not. So we don't need this bucket for now. Control X, Control Y. We remove this. Yeah. So for number in range 2 comma number to check. So the number that we are checking. So I'm going to say if number to check modulus number, that is if we divide number by number to check. And what does that mean? Let's say the number to check here is 12. So I think for number in range 2 to 11, if we can find any number between 2 and 11 that can divide 12, it means 12 is not prime. So we say if number modulus number equals 0, then that's all. We just print um, f string number to check is not a prime. Then we can come here and say, let's just do this for now and say else print, and this only shows the power of indentation. Print number to check is prime. So we should run this. I'm passing, let's use the same 12 that we see, and we're going to see a very weird behavior. So it goes, can you see it says 12 is not a prime, 12 is not a prime, 12 is not a prime, 12 is prime, 12 is not a prime, 12 is prime, 12 is prime. And what is happening here is this. First thing that, the reason why I printed this out is because the first thing that it checks is, in the range is 2 abi, so it says 12 modulus 2 equals 0. True, this is going to be true because 2 can go in 12. It says 12 is not a prime. Then the next one that it checks is 3. 3 also can go in 12. 4 also can go in 12. 5 cannot go in 12, so it says 12 is prime, even though in real life 12 is not prime. What does that tell us? That tells us that in the true solution of checking whether a number is prime or not, you only need to see one thing. The moment you see one thing that can go, you don't need to see other things. And that introduces us to the concept of break. So once we find only one thing that fulfills this condition, we break it. We don't need to check the other things. So I'm going to run this and say 12 again. So it says 12 is not the prime. 12 is not the prime because um 2 can go in it, and that's all we need to know. So if we check for 16, which one? 18, or I don't know, 9. We check for 9. It says, look at what has happened. Even though we've done that, it says 9 is prime, 9 is not a prime. Why is that? Because the first time this thing runs, this is not the place that gets executed, right? Because 2 cannot go in 9, right? Then next one that it checks is 3. 3 cannot go, 3 can definitely go in 9. So it says 9 is not a prime. So what does that mean? It means this our else. For example, let me show you for 11. 11 is definitely a prime, and it's going to just keep printing 11 is a prime, 11 is a prime, 11 is a prime. So if we go here and say 11, and I hope that is going to make us understand more. And yes, it says 11 is prime, 11 is prime, 11 is prime. It's because it checks for 2, checks for 3, checks for 4, checks for 5, and each one of them, there is none that can divide it. What does that tell us? The solution, the indicator to whether something is prime or not, is actually with outside of the loop itself. What does that mean? For me to decide that 11 is prime, I must have checked through all the numbers that are below 11, starting from 2. If all of them are not, then that is now when I say, okay, this number is a prime. Not by me checking 2. Okay, 2 cannot go, then so far so good, 11 is a prime. 3 cannot go, so far so good, 11 is a prime. No, it does not work like that. So I need to move this else backwards outside of the loop, and this one also backwards outside of the loop. So if I should run this and give it 11 again, it says 11 is prime. And if I should give it 9, it says 9 is not a prime, which is the correct solution for this particular problem. So that is the basics of for loop, and in the next one we are going to be getting while loop. We are going to be checking while loop, and what we've seen for loops, how to create it, the anatomy of a for loop. We've also seen how to loop over different data structures, different iterators. We've also seen nested for loops, and we've seen um, for loop with conditionals, and we've also seen for loop with keywords like break. So in the next one, we are going to look at while loop. Can't wait to um, share that with you. Thank you. See you in the next one.